This is the iconic Bf-109. It was the workhorse of the German Luftwaffe during World War II and the deadliest fighter in history. In this video we'll focus on the most produced G or Gustav variant. In particular, we'll look at the G6, of which more than 12,000 examples were produced. When the G6 model became operational in the first months of 1943, it wasn't a super fighter when compared with its adversaries, but it was a solid design that could fill many different roles, and the G6 model saw combat in every theater of German operations. The G6 had a typical all-metal construction with a single spar wing and fabric-covered control surfaces. During the design, much emphasis was put on lightness and ease of maintenance in operational conditions. The structure was mainly riveted with flush countersunk rivets used on external surfaces to reduce drag. The plane measured 22 feet 4 inches in length and stood 8 feet 6 inches tall on its wheels, and the wingspan was 32 feet 7 inches. The plane had an empty weight of just over 6,000 pounds, and when fully loaded, it weighed 7,716 pounds. The fuselage consisted of 10 sections. The front section included the engine and machine guns. The second section included the cockpit, and under the cockpit floor was a fuselage middle beam, upon which the wing spars were attached. The third section incorporated an L-shaped fuel tank. The most important parts positioned in the sections behind was the radio equipment and tail wheel shock strut at the rear. The construction technique of the rear fuselage behind the cockpit was a peculiar feature of the Bf-109. Each section in the fuselage was made from two halves. These two halves were put together with horizontal rows of rivets on top and bottom of the sections. To put the fuselage sections together, each half section was bent inwards. This way, they were connected through flanges. The two sections were then put together with a single line of vertical rivets. The longitudinal stringers were pushed through the holes in the frame. This made for a strong and lightweight fuselage. The Bf-109 was comparatively well armored. The windshield and the rear section of the opening canopy were reinforced with 2.36 inches of laminated armored glass. Behind the pilot's seat, there was 0.43 inches thick armor and a 0.86 inches layered duralumin armor behind the fuel tank. The first units of the G6 had steel armor behind the pilot's head that were 0.43 inches thick. Although in later models, the gallant armor was introduced, and it consisted of an armored glass panel behind the pilot to improve visibility. The tail section was a separate module, and was attached with bolts to the fuselage frame. Most G6 models had a typical all-metal tail with fabric-covered control surfaces. On most 109s, there were no other trim controls for the pilot except the elevator trim. A trim wheel was on the left-hand side of the cockpit, and it changed the angle of the horizontal stabilizer. Besides using the trim on normal flight conditions, it was also important to maintain control in high-speed dives. The wings of the 109 had a single spar. Both wings were attached to the fuselage with bolts. The installation and removal of the wings was relatively simple, and after removing the wings, the fuselage still sat upon its undercarriage. Coolant radiators were installed just below both wings near the wing root. The coolers had hydraulically operated adjustable metal flaps in the front and rear. During the flight, these flaps were automatically controlled and adjusted with the help of the thermostat. Only during the landing, the radiator flap control was changed to manual and the coolant flaps were fully opened, to increase the drag and improve the effect of the landing flaps. The coolant system however, was a notorious weak spot of the Bf-109, as only minor damage could disable the system and nearby cause the engine to seize. Although the pilot could shut the damaged radiator from the coolant circuit, if the problem was noticed in time. Ailerons were duralumin covered with linen fabric. All metal landing flaps were located between the radiator flaps and the ailerons. A peculiar feature of the 109's wings was the leading edge slats. At certain angles of attack, the negative air pressure on the surface of the wing pulled out the slats. They opened automatically as the speed decreased below 124 miles per hour on level flight, and at higher speeds under G-load on tighter turns. These slats improved the plane's low speed and stalling characteristics, but the slats were not synchronized, and they could open asymmetrically on turns, which in turn could disturb the pilot's aim during a dogfight. In a typical combat engagement against bombers, the pilot would climb to 26,000 feet. The Bf-109 climbed well, and the time to altitude was about 10 minutes. While climbing, the pilot would turn on the oxygen system. The 109 would rarely fight alone, and as the pilots approached the combat area, weapons would be switched on. The standard armament consisted of one 20mm MG-151 cannon installed between the cylinder blocks and firing through the hollow propeller axle. In addition, there were two 13mm MG-131 machine guns installed over the engine, right in front of the cockpit. The machine guns created noticeable bumps on the cowling. They are a feature of the model. Each 13mm machine gun held 300 rounds of ammunition, and the cannon magazine contained 200 rounds. The muzzle velocity of the 13mm machine guns was around 700 to 750 meters per second, and the rate of fire was around 900 rounds per minute or 20 seconds of continuous fire. For the 20mm cannon, the muzzle velocity was 700 meters per second and the rate of fire around 700 rounds per minute, or about 17 seconds if the pilot continuously fired. The pilot would generally engage enemies at a maximum distance of 760 yards, but the ground crew could adjust the guns to converge at different distances depending upon the pilot's preference. The guns were able to be effective at longer ranges. In tests, the MG-131 was found to be able to hit on target over 1 mile away. The weapons were charged electrically, and white markers would appear above the ammunition counters to show that the weapons were ready. It was also possible to carry either a bomb or a drop tank under the fuselage. This could be a 79-gallon drop tank, a 551 pounds bomb, or a 551 pounds cluster bomb, or even a 1,100 pounds bomb, but if carrying that large a bomb, the plane's performance suffered greatly. Bf-109s attacked in smaller flights, such as pairs or groups of 4 fighters. The leader of the group would maneuver to a favorable position and then start to engage. The Bf-109 G6 used a KG-13A stick. Before firing, the pilot first pulled the security switch forward, revealing a cannon button in the center. The cannon could be fired with the thumb, and machine guns could be fired with an index finger. If the enemy had escorting fighters, the Bf-109s would frequently have time for one pass before the escort fighters could be on their tails. In a tight formation, they would charge against the bomber formations and choose their targets and fire. After the attack, the German formation would scatter to individual planes and pairs. They would then need to switch their attention to the large numbers of escorting fighters before they could regroup or make a new pass against the bombers. When low on fuel and ammo, and if damaged or in an unfavorable position, the pilots could attempt to disengage and return to their airfields. The DB605A1 engine was a 12-cylinder inverted V engine with a maximum power output of 1,475 horsepower, 1,100 kW, at sea level on emergency power. This engine could propel the Bf-109 to a maximum straight level speed of 400 miles per hour and could reach a maximum speed of 466 miles per hour in a dive. Beyond this speed, the airframe could become unstable. The plane had a very fast climb rate of 3,543 feet per minute and a maximum altitude of 39,000 feet. Such a powerful engine required active cooling to avoid overheating. Therefore, the DB605 engine was equipped with a cooling system featuring two radiators positioned below the wings near the wing roots. The radiators were connected to two metal header tanks on either side of the engine that cooled the engine with a mixture of water and glycol. The hot coolant was chilled by the oncoming airflow before returning back to the engine. The DB605A engine could operate at a maximum of 2,800 revolutions per minute for short periods. However, it was more usual to operate at 2,300 revolutions per minute, at which it would produce a continuous power output of 1,080 horsepower, 805 kW. There was an automatic supercharger that was crucial for maintaining consistent power, especially at high altitudes. The supercharger received air from an intake on the side of the fuselage. The air traveled through a pipe to a 16-blade centrifugal impeller, which compressed the air before feeding it into the cylinders. During climbs and intense maneuvers such as dogfights, the supercharger boosted the intake pressure, providing a power boost. But the supercharger could overpressure the engine if the pilots were not careful. The propeller was metal-bladed and it had a diameter of 9.8 feet. It was fitted with an automatic propeller pitch adjusting mechanism that greatly lessened the pilot's workload in combat situations. A horseshoe-shaped oil tank with a volume of 9.51 gallons was installed in the front part of the engine. The oil cooling system was installed below the engine. The engine had two major overhaul periods, and each overhaul was conducted after 100 hours of flying. Throughout its operational history, one of the most serious drawbacks of the 109 was its limited range. The main fuel tank was an L-shaped, self-sealing rubber tank with a capacity of just over 105 gallons. Internal fuel provided only about 1.5 hours of flying time on combat missions, or around 161 miles of combat range. The fuel was fed into the cylinders via an injector system and two high-pressure pumps that sucked fuel from the tank. Standard G6 models used 87-octane fuel. That was a significant plus, as fuel with a higher octane rating was difficult to obtain in sufficient quantities. The 109's high-altitude performance was better than that of the WWII, which was especially important in defense missions on the Western Front. Due to the plane's limited range with internal fuel, especially on the Western Front, the external fuel tank was almost a standard item on combat missions. On the Eastern Front, this lack of range was not so huge a problem, as most of the action happened around the front lines and German airfields were usually located within a short distance from the front line. The external fuel tank had a capacity of just over 79 gallons. With an external fuel tank, the operational range was increased to 280 miles. Fuel flowed from the external fuel tank to the main tank with the use of pressurized air. The pilot could monitor the fuel flow through a transparent tube inside the cockpit, and when he saw air bubbles or dirty fuel, the pilot knew that the external tank was empty. The landing gear was hydraulically operated. The G6's tailwheel was non-retractable. There was no emergency mechanism for retracting the landing gear, but the pilot could lower the landing gear in a case of hydraulic failure. A T-shaped handle on the right side of the pilot released locking pins on the landing gear. The gear would then lower under its own weight in order to fully extend the gear. However, the pilot was instructed to roll from side to side. The landing gear was the weak point of the airplane. It is estimated that around 10% of Bf-109s were lost during takeoff and landings because of narrow landing gear. This caused problems for inexperienced pilots due to tip-overs. For field maintenance, it was possible to make large repairs and replace the wings while the plane was standing on the undercarriage. It was also possible to load the plane onto a train car or to attach the fuselage to a car so that the plane could be transported by road. This feature helped a lot in maintaining the planes in difficult field conditions, and when recovering and transporting damaged planes to repair plants. A well-known feature of the Bf-109 was its very tight and cramped cockpit. This was especially noticeable when the 109 was compared with American planes. This small cockpit had its benefits, as the cockpit was well designed, and all the switches were within easy reach. The windscreen was a bulky-looking item with heavily welded frames. On a standard version, the canopy consisted of 3 parts, with the middle section being movable. On the left-hand side of the cockpit, the most noticeable features were 2 large handwheels to operate the flaps and the elevator trim. On the left side, the pilot had a primer pump throttle lever. On the throttle lever, the pilot had a rocker switch for adjusting the prop pitch manually, fuel selector, tail, wheel lock, and a canopy emergency release handle. On the right-hand side, the pilot had oxygen system controls, radio switches, on the floor as 2 gray boxes, and radiator control switches, as well as the main circuit breaker panel. There was a large yellow tube fitted with a small transparent tube inside. Through this tube, fuel from the external tank was fed to the main tank. And from the transparent panel, the pilot could monitor to see the fuel was flowing correctly. The main instrument panel had basic but adequate instruments. On the bottom left corner were the landing gear indicator lamps and the landing gear push rods. On the left-hand side and in the center of the panel was the navigation instrument panel with compass, speed indicator, altimeter, and air combined artificial horizon and turn bank indicator. On the right-hand side of the artificial horizon was the boost pressure gauge, and below it was the RPM gauge. Next to the RPM gauge was a propeller clock, prop pitch indicator. On the right was the coolant temperature gauge, fuel gauge and combined fuel, oil pressure gauge. Next to the fuel gauge was the red low fuel warning light, that was meant to turn on when there was fuel left for a maximum of 20 minutes of flight. The upper part of the instrument panel was dominated by the WWII-16B gun sight and its mount. In emergencies, the gun sight could be pushed forward and turned sideways, so the pilot's head would not hit the gun sight in a rough landing. It was also possible to rapidly remove the gun sight from its mount. On the left-hand side were the ammunition counters, with vertical bars showing the machine gun ammunition and the middle bar showing the cannon ammunition. The clock was located on the upper right-hand side of the instrument panel, below the gun sight. Before starting up, the canopy would be closed, so that the airflow could not break the canopy. The trim would be moved to the 1 position and the battery switched on. The prop pitch controller would be switched on and the propeller switched to manual. Then the propeller pitch indicator would show 12 o'clock. After that, the propeller was returned to automatic, and the propeller pitch indicator showed the 12:30 position. Fuel valves would be opened. Throttle would be opened a third. Coolant radiator set to manual and fully opened. and the pilot gave 4 to 6 pumps from the primer pump. Fuel lines were filled by activating the electric fuel pump. When the mechanic gave the sign, the magneto switch would be moved to position M12. The starting handle would be pulled powerfully with the left hand. The pilot would press the pump while the engine ignited. When the engine started, the throttle would be decreased slightly. After checking fuel pressure and the engine was running properly, the electric fuel pump would be switched off. To taxi, the pilot would release the brakes and the plane would start to move. While taxiing, the plane is only controlled by using the brakes. It was difficult to see in front of the 109 while taxiing, and so visibility was very poor. To counteract this, the pilot made S-turns while taxiing. Often there was also a mechanic sitting on the wing giving directions. For takeoff, the pilot would ensure the canopy was closed, tail wheel was locked, and a trim adjusted to 1. Flaps would be set to 20 degrees open, and propeller to automatic. The coolant radiator would be set to automatic and electric fuel pump switched on. The engine power would be steadily increased until the boost pressure reached 1.48 The 109 was known to swing right and left on takeoff, and the movement had to be countered by appropriate use of rudder, which could cash out inexperienced pilots. At 62 miles per hour, the tail would lift, and at that point, the rudder became much more effective. When the speed reached just over 105 miles per hour, the plane would lift. Just after lift-off, the pilot would brake the wheels to stop them from spinning and retract the landing gear. The Bf-109 is the most produced single-seat fighter aircraft in history, with a staggering number of 34,000 units built. It saw combat in a wide variety of environments, from the freezing cold of the Arctic theater to the heat and sand of the Mediterranean, and from treetop heights on the Eastern Front to the edge of the stratosphere in the defense of the